Hello, today we're going to be looking at finding the domain of a function. So first, the domain of a function is the set of all possible values that can be used for the independent variable. That's kind of a mouthful. So another way of thinking of that is, remember our independent variable is x. What values of x make the function work? So for what we're looking at today, if you kind of peek down here with the equations, is we're going to be looking at equations and saying what the domain of the function is. The big thing we're going to be looking for is basically values of x that break the function or make it not work. So back up here, the two big things that we'll have to watch out for today, things that make a function not work, are dividing by 0. So if you have x or some sort of expression that has x in the denominator of a fraction, we need to make sure that that fraction denominator is never 0, because that would mean we would be dividing by 0, which we know is undefined. We also need to make sure that we don't end up with any negative numbers under square root signs. The square root of a negative number is also undefined. So those are the two things to really watch out for. For a lot of functions, especially if you don't see any fractions or square roots in the function, the domain is all real numbers. Because I can take any value of x, plug it into the function, and evaluate it like we did in the last homework, and get a number back. Let's try a few out. So for all of these, we want to state the domain. If it's all real numbers, we're going to say all real numbers. If it's not all real numbers, we're going to basically list what doesn't work. So let's look at number 1. F of x equals 2x plus 3. I don't see any fractions. I don't see any square root signs. And so here's my x. Any number I plug in for x here, I'll be able to get a number on the other side of the equal sign, because there's nothing that's saying that I will have an undefined number for x here. So this one, or when I plug in a number for x, I'll get something that's undefined. This one is simply all real numbers for my domain. So our answer here for our domain, all real numbers. Number 2, same idea. Notice these equations look pretty similar to each other. The fact that we have a negative in front of x is not a big deal. I don't see any fractions. I don't see any square roots. There are no values of x that would break this function and make it not work. So this one is also all real numbers for the domain. All right, the next two have square roots in them. Square roots, we don't want to have any negative numbers under the square root. So the way we tackle that is we want to make sure that whatever is under the root is always greater than or equal to 0, because numbers greater than or equal to 0 are not negative. Numbers less than 0, we get to negative. So the way we deal with these is we take whatever's under the root, x plus 8 in this case, and set it greater than or equal to 0 like this. And then we solve. So what do I need to do to get x by itself? I need to subtract 8 from both sides of my inequality. So I end up with x is greater than or equal to 8. So my domain for this problem is x is greater than or equal to negative 8. If I plug in negative 8, I get exactly 0. The square root of 0 is 0. If I plug in any number bigger than negative 8, I'll get some sort of positive number, which I can take the square root of. Any number smaller than negative 8 would make a negative under the radical square root sign. Let's try another. So also has a square in it. We're going to do it the same idea. We're going to take the stuff under the root, in this case 2x minus 4, set it greater than or equal to 0. Let's solve that inequality. First, I add 4 to both sides. I get 2x greater than or equal to 4. Then I divide both sides by 2. I get x greater than or equal to 2. If I plugged in 2 here, 2 times 2 is 4, minus 4 is 0. So we get exactly 0, which I can take the square root of. If I plug in any number bigger than 2, I'll get a positive number, which I can also take the square root of. So our domain here is x is greater than or equal to 2. The last two will involve fractions. So quickly look back at our rules. We want to make sure that we're not dividing by 0. AKA, we do not want our denominator of a fraction, the bottom part of a fraction, equals 0. So this is going to be similar to what we did with our square roots, but now we have to think about not being equal to 0. So what I'm going to do here is I'm going to take the denominator of my fraction and set it equal to not 0, using the not equal sign. I want x minus 3 to not equal 0. To solve that, I just simply add 3 to both sides, and I get x is not equal to 3. So then my domain is any value of x. I can plug in any number of x I want, except for 3, because if I plug in a 3 here, I get a 0. Anything divided by 0 is undefined. So this kind of is going to involve this x not equal to 3 and all real numbers, because my domain is all real numbers except whatever one I can't be equal to. So since x cannot equal 3, I'm going to say all real numbers except x equals 3. Any other number I plug into that fraction, I'll be able to get some sort of number when I evaluate and simplify, unless my x value is 3, because I'd be dividing by 0. Let's try one more. So this 3x part doesn't have a fraction in it, not a big deal. If my function was just f of x equals 3x, it would be all real numbers. The part I have to watch out for is the fraction part, 5 divided by x. This cannot equal 0, so I need to say x cannot equal 0. I cannot solve it any further, so the only value that makes this function not work is 0. So once again, my domain is going to be all real numbers except the one that doesn't work, which is 0. So except x equals 0. So that's a quick little intro to how to find your domain from an equation. That is it for today. Have a fantastic day.